The solution of the differential equation e raised to dy by dx is equal to x plus 1 is given as e raised to dy by dx is equal to x plus 1. So therefore dy by dx will be log of x plus 1. So dy is equal to log of x plus 1 dx. Integrating both sides, we get y is equal to, now integration of log x plus 1 is x log x plus 1 minus integration of x into derivative of log x, that is 1 by x plus 1 into dx plus c. So this will be log of x plus 1, x log x plus 1 minus, we can write this as x plus 1 minus 1 by x plus 1 into dx plus c, that is equal to log of x log x plus 1 minus, now we split the terms, so this will be integration of 1 minus 1 by x plus 1 dx plus c, and this is equal to c. So now we integrate this will be x log x plus 1 minus integration of 1 is x, minus into minus is plus, log of x plus 1 plus c, and this is equal to y. So when x is 0, y is 3, that is y of 0 is 3. So this means when x is 0, y is 3. So y was x log x plus 1 minus x plus log of x plus 1 plus c. We substitute these values, this will be 3 equals 0 log of 0 plus 1 minus 0 plus log of 0 plus 1 plus c. So log 1 is 0, so everything will be 0, this term will be 0, so 3 equals c, that is c will be 3. So we got the value of c, we substitute this, we'll get y equals x log x plus 1 plus log of x plus 1 minus x plus 3. So bringing these two terms together, so we take log of x plus we take log of x plus 1 common in these two terms, so this will be log of x plus 1 into x plus 1 minus x plus 3, and this is equal to y. So now we compare it with the options. So this is y is equal to log of x plus 1 into x plus 1 minus x plus 3 minus x plus 3. So the answer is B, y equals x plus 1 log of x plus 1 minus x plus 3. The given differential equation is dy by dx is equal to 1 plus y square plus x plus xy plus xy square. We have to find the solution of this differential equation. So this is equal to dy by dx. Now we can write this term as 1 plus y square into x plus 1. That is, we factorize this, and now we shuffle terms, that is, we separate x and y terms. So 1 by 1 plus y square into dy is equal to 1 by x plus 1 into dy. So integrating both sides, now we can write this term as 1 by y plus half the whole square plus 3 by 4. This term we write this as y plus half raised to 2 plus 3 by 4 dy is equal to, now and we integrate this, so integration of x is x square by 2, integration of 1 is x plus integration constant. So this is in the form of 1 by x square plus 1, integration of 1 by x square plus 1 is tan inverse of x, So here this will be that is, here it is in the form of 1 by x square plus a square. So it will be 1 by root 3 by 2 into tan inverse of y plus half divided by root 3 by 2, and this is equal to x square by 2 plus x plus c. So so shuffling the terms, will get 4 tan inverse of 2y plus 1 by root 3 is equal to root 3 times x square plus 2x plus 2 root 3 c1. Let this be let this constant be c into c. So let this constant be c1. So now we compare it with the options. 4 tan inverse of 2y plus 1 by root 3 is equal to root 3 times 2x plus x square plus c. So the answer is D. 4 tan inverse of 2y plus 1 by root 3 is equal to root 3 times 2x plus x square plus c. dy by dx is equal to y plus 3, then and y of 0 equals to, then y of log of 2 is equal to, so given is dy by dx equals y plus 3, so therefore 1 by y plus 3 into dy is equal to dx. Now we integrate both sides, so this will be log of y plus 3 is equal to x plus c. So this is a solution, general solution. So for particular solution, the condition is given as for x equals 0, y equals 2. So we substitute the values. So log of y equals 2, so log of 2 plus 3 is equal to 0 plus c. So therefore c is log 5. And now we substitute this in general equation. So log of y plus 3 is equal to x plus log 5. So for x equals log 2, this will be log of y plus 3 is equal to log of 2, x is log 2 plus log 5. So by law of logarithm, we can write this as log of 2 into 5, and this is equal to log of y plus 3. So therefore we can say y plus 3 is equal to 2 into 5, which is equal to 10. So y plus 3 equals 10. Therefore y is equal to 7. So the answer is A, 7. The solution of differential equation y dash equals 1 plus x plus y square by y square plus x y square is when y of 0 is 0 is we have the general the differential equation is given, condition is given, we have to find the particular solution. So given is y dash can be written as dy by dx, so this will be dy by dx is equal to, now we can write this term as 1 plus x into 1 plus y square. We factorized it. Now we shuffle the terms, that is separate x and y terms. So 1 by 1 plus y square into dy is equal to 1 plus x into dx. And now we integrate both sides. This is in the form of 1 by 1 plus x square. Integration is tan inverse of y. For this it will be x plus x square by 2 plus c, integration constant. So condition is when x is 0, y is 0. So tan inverse of 0 is equal to 0 plus 0 plus c. So therefore c is equal to 0, since tan inverse of 0 is 0. So we got the value of c. So the general equation, the particular equation with the value c will be tan inverse of y plus x square by 2 is equal to x plus x squared by 2, since c is 0. So tan inverse of y is x plus x squared by 2. Therefore y will be equal to tan of x plus x squared by 2, which is option D. If 2 plus sin x by 1 plus y dy by dx is equal to minus cos x, then y of 0 and y of 0 is 1, then y of pi by 2 is what? So first we shuffle the terms. So dy by 1 plus y will be equal to minus cos x upon 2 plus sin x dx. What we did was separate the x terms and y terms. So now we integrate this. So integration of LHS will be log of 1 plus y. And now if we notice, this derivation of denominator will be numerator. So the integration of this will be minus of log of 2 plus sin x. That is using substitution, where 2 plus sin x will be t. So therefore minus cos x, this will be plus. This is minus. So plus cos x will be, cos x dx will be dt. So we substituted this. So we'll be getting minus log of 2 plus sin x plus log c, where this is integration constant. So log of 1 plus y plus log of 2 plus sin x is equal to log c. So therefore now using law of logarithm, this will be log of 1 plus y into 2 plus sin x is equal to log c. Therefore 1 plus y into 2 plus sin x is equal to c is equal to c. So what is given is, when x is 0, y is 1. So we put x equals 0 and y is 1. This will be 1 plus 1 into 2 plus sin 0 is equal to c. So c will be 2 into 2, which is 4. So c is 4. So the solution equation will be 1 plus y into 2 plus sin x equals c. Now we put x equals pi by 2. So we'll be getting y. So this will be 1 plus y, 2 plus sin pi by 2. This will be sin pi by 2. Sin pi by 2 is 1. So 2 plus 1 is equal to c is 4. So 1 plus y will be 4 by 3. So therefore y will be 1 by 3. Y will be 1 by 3. So the answer is C, 1 by 3. Given differential equation is x plus y the whole square dy by dx equals a square. So that is dy by dx will be a square by x plus y the whole square. Now we put x plus y equals v. So therefore 1 plus now differentiating with respect to x. So this will be 1 plus dy by dx is equal to dv by dx. Therefore dy by dx will be dv by dx minus 1. So substituting this here, so dy by dx is dv by dx minus 1 is equal to a square upon v square. So therefore dv by dx will be equal to a square upon v square minus 1, which is equal to plus 1, which is equal to a square plus v square by v square. So we shift v terms on one side and x terms on the other side. We will get v square upon a square plus v square dv is equal to dx. Now integrating both sides. So we had integration of v square by a square plus v square dv is equal to integration of dx. So integrating, we get, now we can simplify this as one minus a square upon a square plus v square, the alternate form for this, into dv, and this is integration of x dx, integration of dx. So integrating these terms now, we'll get v minus, for this it is a into tan inverse of v by a is equal to integration of dx is x plus integration constant c. But v is x plus y, so this will be x plus y minus a tan inverse of x plus y by a is equal to x plus c. So shifting terms on the other side except y, we get y equals a tan inverse of x plus y by a. Now x gets cancelled on both sides, so we are left with a tan inverse of x plus y by a plus c, which is option D, none of this, since none of the option contain the term tan inverse of x plus y by a. The solution of differential equation dy by dx plus 1 equals e raised to x plus y is, so given is dy by dx equals e raised to x plus y minus 1. Taking this to RHS. Now put x plus y equals v. So therefore, integrating with respect to x, we'll get 1 plus dy by dx is equal to dv by dx. So we substitute this. So dy by dx is dv by dx minus 1 is equal to e raised to v minus 1. So minus 1 gets cancelled. So dv by dx is equal to e raised to v. So therefore, e raised to minus v dv is equal to dx. So integrating both sides, we get minus e raised to minus v is equal to x plus c. So shifting terms to one side, we'll get x plus e raised to minus v plus c equals 0. But v is x plus y. So final answer will be x plus e raised to minus x plus y in brackets plus c equals 0. That is option A, where it is x plus c plus e raised to minus of bracket x plus y. So the answer is A. Now given differential equation is cos of x plus y dy is equal to dx. So therefore dy by dx will be 1 by cos of x plus y. We have to find the solution for this differential equation. So put x plus y equals v. So therefore differentiating with respect to x, so we get 1 plus dy by dx is equal to dv by dx. So dy by dx is dv by dx minus 1 is equal to 1 by cos v. That is dv by dx is equal to 1 by cos v plus 1. This is equal to 1 plus cos v upon cos v, and this is equal to dv by dx. So therefore cos v upon 1 plus cos v dv is equal to dx. Integrating both sides, so previous term was integration of cos v by 1 plus cos v dv is equal to integration dx. First we'll simplify this. So cos v can be written as 2 cos square v by 2 minus 1, and 1 plus cos v can be written as 2 cos square v by 2 into dv is equal to integration of dx. So this is equal to 1 minus 1 by 2 sec square v by 2 integration of into dv. This is equal to integration of dx. So now we integrate this. So we get v minus integration of sec square is tan. So minus tan of v by 2 half divided by half, since the coefficient of v is half, is equal to x plus c. So v minus half gets cancelled, v minus tan of v by 2 is equal to x plus c. So we resubstitute this as v equals x plus y. So x plus y minus tan of x plus y by 2 is equal to x plus c. X gets cancelled, we are left with y equals, bringing this to RHS, tan of x plus y by 2 plus c, which is option A, y equals tan of x plus y by 2 plus c. The given differential equation is dy by dx equals x minus 2y plus 1 into divided by 2 into x minus 2y. So we have a term x minus 2y which cannot be separated. So we simply put x minus 2y equals v. So therefore differentiating this with respect to x, so we'll get 1 minus 2 into dy by dx is equal to dv by dx. So therefore dy by dx will be 1 minus dv by dx into 1 by 2. So we substitute this and these terms in the given differential equation. So dy by dx will be half into 1 minus dv by dx, x minus 2y is v, so v plus 1 upon 2v. So half gets cancelled. We are left with 1 minus dv by dx is equal to, now we can write this as 1 plus 1 by v. So 1 gets cancelled again. So we are left with dv by dx equals minus 1 by v. Therefore minus v dv is equal to dx. Integrating both sides, we get minus v square by 2 is equal to, or rather plus v square by 2, shifting this to RHS, equals minus x plus c. But x is x minus 2y, v is x minus 2y, so this will be x minus 2y the whole square, and multiplying throughout by 2, we get minus 2x plus 2c. So this is equal to x minus 2y the whole square plus 2x equals, let this constant be c1. So this will be c1. So x minus 2y the whole square plus 2x equals c, which is option A. X minus 2y the whole square plus 2x equals c. The differential equation is given by dy by dx equals sine of x plus y into tan of x plus y minus 1. So we have to find the solution of this differential equation. So this is an implicit function. So we'll put x plus y equals v. So therefore 1 plus dy by dx will be equal to dv by dx. So dy by dx is dv by dx minus 1 is equal to sine v into tan v minus 1. So minus 1 gets cancelled. Well, if minus 1 gets cancelled, so dv by dx is equal to, now we convert everything into sine and cos. So this is sine v by cos v. So this will be sine square v by cos v. So that is cos v by sine square v dv is equal to dx. Integrating both sides, we will get, this is x and now if we put sine v equals t, so cos v dv will be equal to dt. So this will convert into integration of 1 by t square dt. So integration of 1 by t square is minus 1 by t. So this will be minus of 1 by t, where t is sine v. So this is equal to minus 1 by sine v is equal to x plus c. So we resubstitute x plus y equals v and multiply it throughout by sine v. So we'll get minus 1 equals x or we can bring this to RHS, and sine v, 1 by sine v is cosec v. So minus of cosec v is x plus y is equal to x plus c. So therefore x plus cosec x plus y is equal to c, which is option B. X plus cosec x plus y is equal to c, which is the answer. Solution of dy by dx equals y square by xy minus x square is first step is put y equals vx. So therefore dy by dx will be v plus x dv by dx. So we substitute this here. So dy by dx is v plus x dv by dx is equal to y square is v square vx square. So v square x square divided by x into vx minus x square. This is equal to v square minus v upon 1. V square upon v minus 1. And this and bringing this term to RHS. We bring this term to RHS v. So this will be x dv by dx equals this term. So this term is v upon v minus 1 into x dv by dx. So separating x and v terms, we get v minus 1 upon v dv is equal to 1 by x dx. So that is equal to 1 minus 1 by v dv is equal to 1 by x dx. So integrating both sides, we get v minus log v is equal to log x plus log c. So v is equal to log of x minus plus log v plus log c. So by law of logarithm, this will be equal to log of x into v into c. So therefore b will be equal to v was log of x into v x v c. So e raised to v will be x into v into c. But v is y by x. So e raised to y by x will be, now x into v is y, so this will be equal to yc. But in the options it is the constant is k, so we'll replace c with k. So e raised to y by x will be yk, which is option B. E raised to y by x is equal to ky. Given differential equation is x dy minus y dx equals root of x square plus y square dx. So x dy will be equal to y dx plus root of x square plus y square dx. Taking dx common and bringing it alongside dy by dx, dy, this will be dy by dx is equal to y plus root of x square plus y square divided by x. So first put y equals vx. So therefore dy by dx will be v plus x dv by dx. So v plus x dv by dx will be equal to vx plus root of x square plus v square x square divided by x. So taking x common, also from the square root, we get v plus root of 1 plus v square into x divided by x. So x gets cancelled. Here we have v plus x dv by dx. So x dv by dx will be v plus, now v gets cancelled. So we are left with root of 1 plus v square. So 1 by root of 1 plus v square dv is equal to 1 by x dx. So continuing this, 1 by root of 1 plus v square dv is equal to integration of 1 by x dx. We integrated both sides. So integration of this is log of v plus root of 1 plus v square, and this is log of x plus log c, which is integration constant. So which is equal to log of x into c by law of logarithm. So we can say v plus root of 1 plus v square is equal to x into c. Now we resubstitute v equals y by x, so this will be y by x plus root of 1 plus y square by x square is equal to xc. So y by x plus root of x square plus y square by x is equal to x into c. Multiplying throughout by x, we get y plus root of x square plus y square is equal to x square c. See, so now we compare it with the options. So we can see y plus root of x square plus y square equals x square c is the answer. So D is the answer. Solution of x plus 1 x plus y minus 1 dx plus 2x plus 2y minus 3 dy is equal to 0. So we have to find the solution of this differential equation. So simplifying this, we can write dy by dx is equal to minus of x plus y minus 1 divided by 2x plus 2y minus 3. This is equal to dy by dx. So put x plus y equals v. So 1 plus dy by dx will be equal to dv by dx. So we substitute this here. So this will be dv by dx minus 1, which is dy by dx, is equal to minus of v minus 1 divided by 2 into v minus 3. Bringing negative sign into the bracket and bringing this to RHS, we'll get 1 minus v upon 2v minus 3 is equal to dv by dx. So bringing v terms on one side, we get 2v minus 3 by 1 minus v is equal to into dv is equal to dx. So integrating both sides, we can write this term as integration of 2 into v minus 2 plus 1 divided by v minus 2. We wrote the this was v minus 2 after we brought 1 to RHS. So this was v minus 2. So we converted the numerator in terms of denominator. So this will be 2 into v minus 2 plus 1 divided by v minus 2 into dv equals integration of dx. So this will be, now splitting the numerator, this will be 2 plus 1 by v minus 2 is equal to integration of dx. So integration of 2 plus 1 by v minus 2 dv is equal to integration of dx. So taking integrating the terms, we get 2v plus log of v minus 2 is equal to log of x plus log of c. So 2v will be equal to log of x now we resubstitute v equals x plus y. So this will be 2 into x plus y is equal to log of plus log of x plus y minus 2 is equal to log of x plus log c. This is just x since it is integration of 1 dx. So this will be x, this will be x. So 2x plus 2y plus log of x plus y minus 2 is equal to x plus c. This will be c, just c. So x gets cancelled, we are left with x plus 2y. So this will be 2y plus x plus log of x plus y minus 2 is equal to c. So we compare it with the options. So 2y plus x plus log of x plus y minus 2 is equal to c. So the answer is c. Given differential equation is y into cos of y by x into x dy minus y dx plus x into sine of y by x into x dy plus y dx is equal to 0. So put y by x equals v, therefore y equals vx, therefore dy by dx will be v plus x dv by dx. So substituting this here, we get v first we divided throughout by x, so if we divide throughout by x, we'll get y by x, and this will be x by x, so x gets cancelled. So y by x is v cos v into v plus x dv by dx. Again we divided throughout by dx, so this will be divided by dx, same here. So v plus x dv by dx plus sin v into v plus x dv by dx plus v is equal to 0. So this will be, so this was minus v. This can be simplified to v cos v x dv by dx plus sin v 2v plus x dv by dx equals 0. That is equal to x into v cos v plus sin v dv by dx plus 2v sin v equals 0. That is equal to x v cos v plus sin v dv is equal to minus 2v sin v dx. So bringing v terms on one side and x terms on other side, we get integrating both sides simultaneously. So v cos v plus sin v divided by v sin v will be equal to minus 2 integration of 1 by x dx, and this is dv. So derivative of the denominator is numerator, so this will be log of v sin v is equal to minus 2 log x plus log c, which is integration constant. So by law of logarithm we can write log of v sin v is equal to log of x raised to minus 2 into c. So therefore v sin v will be equal to c by x square. So resubstituting v equals y by x, so y by x into sine of y by x will be equal to c by x square. So x gets cancelled, so this will be y into sine of y by x will be equal to c by x. So now we compare it with the options. Y into sine y by x equals c by x. So this will be y into sine of y by x. So now the value of c is given, so we have to find the particular solution. So what is given is y of 1 is pi by 2. Y of 1 is pi by 2. That is when x equals 1, y equals pi by 2. So substituting this, so this will be pi by 2 into sine of pi by 2 by 1 is equal to c. So therefore c will be, sine of pi by 2 is 1, so c will be pi by 2. So since c is pi by 2, so RHS will be pi by 2. So the final answer will be y sin y by x equals c will be pi by 2, so pi by 2 into x, pi by 2x, which is option C. Y sin y by x equals pi by 2x. So given differential equation is x dy by dx plus y into log x is equal to x into e raised to x 1 by 2 log x. So we have to find the integrating factor. So first we divide throughout by y, since we have to bring this in the form of dy by dx plus py equals q. So dividing throughout by y, we get dy by dx equals y into log x by x equals e raised to x half log x. So here p will be log x by x. So integrating factor will be e raised to integral p dx, which is equal to e raised to integral log x by x dx. So here we put log x equals t. So 1 by x dx will be dt. So this will be e raised to integral t dt, which is equal to e raised to t square by 2. So e raised to t square by 2, which is, now t is log x. So this will be e raised to half log x the whole square. That is, we can write e raised to half log x raised to log x, that is e raised to log of root x raised to log x. This we got from law of indices. So e raised to log of root x to the base e is the same as root x, and this raised to log x. So the answer is C, root x raised to log x is the integrator. Y plus x square equals dy by dx. So we have to bring this in the form of dy by dx plus py equals q. So this will be dy by dx minus y equals x square. So here p will be minus 1. So integrating factor is e raised to integral p dx, that is e raised to minus 1 dx. So this will be e raised to minus x. So integrating factor is e raised to minus x. So solution is y into integrating factor, that is y into e raised to minus x equals integration of integrating factor e raised to minus x into q, which is x square dx into dx plus c. So integration of this will be y e raised to minus x equals minus x square e raised to minus x minus 2x e raised to minus x minus 2 e raised to minus x plus c. After we use u into v rule for integration. So simplifying this, we get dividing throughout by e raised to minus x, we get y equals minus x square minus 2x minus 2 plus c into e raised to x, that is v divided by e raised to minus x. So bringing terms on one side, we'll get y plus x square plus 2x plus 2 equals c e raised to x, which is option A, y plus x square plus 2x plus 2 equals c e raised to x. Given differential equation is dy by dx plus y into x square x equals t. This is in the form of dy by dx plus py equals q. So integrating factor will be e raised to integral p dx, which is equal to e raised to integration of sec square dx. So integration of sec square is tan x. This will be e raised to tan x, which is integrating factor. So solution will be y into integrating factor e raised to tan x is equal to integration of e raised to tan x into tan x into sec square x, since q is tan x sec square x dx plus c. So now we integrate this, put tan x equals t. So sec square x will be sec square x dx will be dt. So therefore y e raised to tan x will be equal to integration of e raised to t dt. So integration of e raised to t into t dt is t e raised to t minus e raised to t plus c, and this is equal to e raised to tan x. Now put again t equals tan x, we get y into e raised to tan x equals tan x into e raised to tan x minus e raised to tan x plus c. So divide throughout by e raised to tan x, we get y equals tan x minus 1 plus e raised to minus tan x. So comparing with the options, the answer is A, y tan x, y equals tan x minus 1 plus c into e raised to minus tan x. dy by dx plus y equals e raised to minus x. This is in the form of dy by dx plus py equals q. So integrating factor is first e raised to integral p dx, that is e raised to integral 1 dx, which is equal to e raised to x. So integrating factor is e raised to x. So solution will be y into e raised to x equals e raised to x into q, that is e raised to minus x dx plus c, that is equal to e raised to x into e raised to minus x is 1. So integration of dx plus c, this is equal to e raised to x. This will be equal to e raised to x and x plus c. So what is given is when x is 0, y is 0. So we substitute the values. So y is 0 equals 0 plus c. So c will be 0. So the final solution is y e raised to x is equal to x. So therefore y will be equal to x e raised to minus x, which is option D. Differential equation is given as x dy by dx equals 2y plus x cube into e raised to x. So we have to bring this in the form of dy by dx plus py equals q. So dividing throughout by x, we get dy by dx equals 2y by x plus x cube e raised to x. That is dy by dx will be dy by dx minus 2y by x equals x square e raised to x. So integration factor will be e raised to integral p dx, that is e raised to integral minus 1 by x dx, that is equal to e raised to here it is 2, so minus 2 by x, minus 2 log x, that is equal to e raised to log of x raised to minus 2, which is now e raised to log of x raised to minus 2 to the base e is equal to x raised to minus 2. This is equal to 1 by x square. And this is integrating factor. So solution is given as y into integrating factor 1 by x square is equal to integration of integrating factor, that is 1 by x square into q, that is x square into e raised to x. So x square gets cancelled. We are left with integration of e raised to x dx plus c, and this is y by x square. So integration of y by x, integration of e raised to x is e raised to x. So y by x square will be e raised to x plus c. So what is given is y when x is 1, y is 0. So when x is 1, y is 0. So we'll get c. So 0 equals e raised to 1 plus c. So therefore c will be e. C will be minus e when this is sent to LHS. So c is minus e. So therefore the solution is y by x square is equal to e raised to x minus e. That is y equals x square into e raised to x minus e. So from the options we can say y equals x square into e raised to x minus e, which is option C, which is the solution. If y of t is the solution of 1 plus t dy by dt minus ty equals 1, then and y of 0 is minus 1, then y of 1 is equal to what? So y of t is the solution. The given differential equation is 1 plus t dy by dt minus ty equals 1. We have to convert this in the form of dy by dt plus py equals q. So we divide through it by 1 plus t. So this will be dy by dt minus t upon 1 plus t into y equals 1. 1 equals 1 by 1 plus t. So integrating factor will be e raised to integral p dt, which is e raised to integration of t by 1 plus t dt. So integration of this term will be e raised to minus t plus log of 1 plus t, which is equal to e raised to e raised to minus t into e raised to log of 1 plus t. So e raised to log of 1 plus t to the base e will be 1 plus t, and this will be as it is, e raised to minus t, and this is the integrating factor. So integrating factor was e raised to minus t into 1 plus t. So solution will be y into 1 plus t into e raised to minus t, which is integrating factor, into e raised to minus t 1 plus t into q, that is 1 by 1 plus t dx dt plus c. So 1 plus t gets cancelled. So this will be integration of minus e raised to minus t dt plus c. So integration of e raised to minus t is minus of e raised to minus t plus c, and this will be y into 1 plus t into e raised to minus t. So dividing throughout by e raised to minus t, we get y into 1 plus t equals minus 1 plus c e raised to t. Now it is given that for x equals minus 1, y is 0. So we'll get the value of c. Y is 0, so y will be, LHS will be 0, minus 1 plus c e raised to minus 1. So c e raised to minus 1 is 1. So therefore c will be e. So value of c is e. So therefore y into 1 plus t will be equal to minus 1 plus e raised to t into e. So what we have to find is for x equals 1, y equals what? So put that is t. Here it is t. So for t equals 1, y equals what? So we put t equals 1. So this will be y into 1 plus 1 equals minus 1 plus e raised to 1 into e. That is 2y equals minus 1 plus this is minus this term isn't there. That's a correction. It is given that when x is 0, y is minus 1, not the opposite. So everything will change. So substituting this in the solution, general solution, we'll be getting c equals 0. So when c equals 0, the whole term gets erased. So y of 1 plus t will be equal to minus 1. So y of 1 plus 1, y of when t is 1, y will be y into 1 plus 1, that is y into 2 will be equal to minus 1. So y will be minus half. So the answer is minus half, which is y of 1, that is when x equals t equals 1. The slope of tangent at x comma y to curve passing through the point 2 comma 1 is x square plus y square divided by 2xy. Then the equation of the curve is, what is given is dy by dx, which is slope, is equal to x square plus y square by 2xy. So the slope is given, we have to find the equation of the curve. So first we'll solve this differential equation. For this, put y equals vx. So dy by dx will be x plus v dv by dx. So x plus v dv by dx will be equal to x square plus x square v square divided by 2 into x into vx. So this is equal to 1 plus v square divided by 2v. This is v plus x dv by dx. So bringing this term to RHS, this will be minus v and this will be x dv by dx. So x dv by dx is 1 minus v square upon 2v. So separating terms, we get 2v upon 1 minus v square dv is equal to dx by x. So 2v upon 1 minus v square dv is equal to 1 by x dx. So integrating both sides, we get minus of log 1 minus v square. Since the denominator, derivative of denominator is numerator, so minus log of 1 minus v square is equal to log of x plus log of c. So resubstituting by v equals y by x. So this will be minus log of 1 minus y by x the whole square will be equal to log of x plus log of c. So condition is the point passes through 2 comma 1. The curve passes through 2 comma 1. So this is equivalent to x comma y. So when x is 2, y is 1. So we substitute the values here. We get minus log of 1 minus 1 by 2 the whole square is equal to log of 2 plus log c. So therefore simplifying this, we get c equals 2 by 3. So resubstituting this here, we get log of x square minus y square by x square minus equals log of x plus log of 2 by 3. That is log of x square by x square minus y square. That is by law of logarithm, bringing the minus term inside the bracket. This will be inverse. So log of x square by x square minus y square will be equal to log of x into 2 by 3. Therefore x square by x square minus y square will be equal to 2x by 3. So shuffling the terms, we get again now x gets cancelled. We are left with 3x will be equal to 2 into x square minus y square. So comparing with the options, we get 3x equals 2 into x square minus y square. So the equation of the curve is A. The function y equals f of x has second order derivative f double dash of x equals 6 into x minus 1. If its graph passes through the point 2 comma 1 and the point the tangent to the graph is y equals 3x minus 5, then the function is, so it is given that f double dash of x equals 6x minus 1. Tangent to the curve is the slope, that is, so f double dash of x is given as 6 into x minus 1. So to get the slope, we integrate this with respect to x. So f dash of x will be integration of 6x minus 1 dx. So this will be 6 into x minus 1 the whole square divided by 2 plus c, that is equal to 3 into x minus 1 the whole square plus c. So this is f dash of x. So now the point passes through 2 comma 1, that is x comma y, and the tangent, the line tangent line is y equals 3x minus 5. So slope of this will be this is in the form of y equals mx plus c. So slope is 3. So we got that for point 2 comma 1 f dash of x equals 3, that is the slope. So f dash of x equals 3 for x comma y equals 2 comma 1. in the previous step we got f dash of x equals 3 into x minus 1 the whole square plus c is the equation of slope, and for point x comma y equals 2 comma 1 slope was 3. So we substitute the values. So f dash of x is 3, x is 2, y is 1, so 3 into 2 minus 1 square plus c, that is 3 equals 3 into 1 plus c. So therefore c will be 0. So integration constant is 0, so therefore f dash of x will be 3 into x minus 1 the whole square. So to get the main function, original function, we integrate this again. So this will be f of x equals 3 into x plus x minus 1 the whole square. Integration is 3 into x minus 1 the whole cube divided by 3 plus c1. So 3 gets cancelled. This will be x minus 1 cube plus c2. This will be f of x. So first, now we have to find c2. So what is given is for x equals 2, y is 1. That is the point which passes through the curve. So we substitute it here. So f of x is f of 2, which is equal to 1, that is y, is equal to 2 minus 1 the whole cube plus c2. So c2 will be 0 since this is 1 and this is also 1. So c2 will be 0. So we get the general particular solution. So f of x will be x minus 1 the whole cube plus 0, that is equal to x minus 1 the whole cube. So the function is x minus 1 the whole cube, which is option B. Now this is a word problem which states the rate of increase of bacteria in a certain culture is proportional to the number present. So rate of increase, let the population be P. Then it is given that rate of increase of population, that is dP by dt with respect to time, that is proportional to P. So removing the proportionality, we get dP by dt equals k into P, where k is constant of proportionality. So next part is, if it doubles in 5 hours, then in 25 hours the number would be what? So when t equals 5, P will be 2 times P original, that is when t was 0. initial one. So what we are supposed to find is P at t equals 25 hours. So given differential equation is dP by dt equals kP. So therefore 1 by P dP will be equal to k into dt. So integrating this, we get log of P will be equal to kt plus c, that is kt plus, okay, so now we have to find c. So the differential equation we got was log of P equals kt plus c. Now when t equals 0, let the population be P0, the initial population. So t will be 0, so this term is 0 plus c. So p will be, this will be log of P0. So therefore P will be log of P0. That is log of original population. So we substitute this back in the general equation. We get log of P equals kt plus log of P0. That is log of P minus log of P0 will be equal to kt. That is by law of logarithm. This will be log of P by P0 will be equal to kt. So now another condition given is when t equals 5 hours, population will double the initial, that is P will be equal to 2 times original population. So log of P, that is 2 times PO divided by PO will be equal to K into 5. So log of 2 will be equal to 5K. So therefore K is log of 2 by 5. See, we got the value of K, we got the value of C. Now we will get the complete equation, which is log of P by P naught is equal to log of 2 by 5 into T. So what we have to find is population after 25 years. 25 population after 25 hours. So when T equals 5, P equals what? So the solution equation was log of P by P naught is equal to KT, which is equal to log of 2 by 5 into T. So T is 25, so this will be log of 2 by 5 into 25. So this will be 5 log 2 log 5 log 2. And this will be log of P by P naught. So 5 log 2 is log of 2 raised to 5. And this is equal to log of P by P naught. Taking anti-logs, we get P by P naught is equal to 2 raised to 5 is 32. So therefore population will be 32 times of original population. So population will be increasing 32 times the original, which is option C. The solution of the differential equation x dy minus y dx equals 0 represents which of the following? So we have to first solve it, then interpret it as per the statements. It can be either a rectangular hyperbola or a straight line passing through origin, a parabola with vertex at origin, or a circle with center at origin. So first we will solve the differential equation, which is x dy minus y dx equals 0. That is x dy equals y dx, that is 1 by x dx is equal to 1 by y dy. So integrating both sides, we get x equals log x equals log y plus log c. That is log of x minus log of y will be equal to log c. That is log of x by y will be equal to log c. So therefore x by y will be equal to c. Therefore x equals yc. Now this is the equation of a line passing through origin. So the answer is B, straight line passing through origin. Let the population of rabbits surviving at a time t be governed by the differential equation. dp of t by t equals half of p of t minus 200. If p of 0 is 100, then p of t is what? So the differential equation is given by dp of t by dt is equal to half into p of t minus 200. Now bringing this whole term to LHS, we get dp of t divided by half of p of t minus 200 equals dt. Now we integrate this with respect to for p of t, and here t is 2 times log of, this is in the form of 1 by x minus a. So this will be 1 log of p of t minus 200 divided by half, that is the coefficient of p of t, is equal to t plus c, that is 2 log p of t minus 200 is equal to t plus c. So this will be log of p of t minus 200 will be equal to t by 2 plus c by 2, dividing throughout by 2. So now raising the power taking antilogs, that is, so this will be e raised to this will be p of t minus 200. This will be equal to e raised to t by 2 into c by 2, that is equal to e raised to t by 2 into e raised to c by 2, and let e raised to c by 2 be a constant, say c1. So this will be e raised to t by 2 into c1, and this is p of t minus 200. Now this is our general solution. So our general solution was p of t by 2 minus 200 is equal to e raised to t by 2 into c1. So now p of 0 is given as 100, 0 is given as 100. So we substitute the values to get the value of c1. So p of 0 divided by 2 minus 200 is equal to e raised to t0. So e raised to 0 into c1. P of 0 is 100, so 100 by 2 minus 200 will be e raised to 0 is 1, so this will be equal to c1. So c1 will be 50 minus 200, which is equal to minus 50. So c is minus 150. So we substitute this in the particular equation, particular solution. So this will be p of t by 2 minus 200 is equal to e raised to t by 2 into minus 150. That is, p of t by 2 is equal to minus 150 e raised to t by 2 plus 200. So bringing this to RHS, we'll get p of t is equal to 400 minus 300 into e raised to 3 by 2. So comparing this with the options, we'll get p of t is equal to 400 minus 300 into e raised to t by 2. That is option C. 400 minus 300 into e raised to t by 2. Solution of the differential equation 1 plus y square dx minus xy dy is, so it is given that 1 plus y square dx is equal to xy dy. Shifting this to RHS, therefore dx by x is equal to y by 1 plus y square, that is separating x and y terms. So we integrate this. So this will be log of x is equal to, now derivative of the denominator is numerator, so integration will be log of denominator, that is log of 1 plus y square divided by 2 plus log c, where this is the integration constant. So log of x will be log of root of 1 plus y square by law of logarithm plus log c. So this is equal to log of c into root of 1 plus y square, which is equal to log of x. So therefore x will be equal to c into root of 1 plus y square. So there is a data missing here. It is said that the curve, this is the equation of the curve, and this curve passes through point 1, 0. So when x is 1, y is 0. So when x is 1, y is 0. So x is 1, y will be 0. So this will be root of 1 plus 1 plus 0, that is equal to c. So therefore c will be 1. So resubstituting, this will be x equals root of 1 plus y square. So squaring both sides, we get x square equals 1 plus y square. Therefore x square minus y square is equal to 1. This is the equation of the curve, which is option B.